So in summary, and remember here we're talking about f of x being equal to p of x over q of x. Help if I could write. Okay. If the degree of p of x is less than q of x, then there is a horizontal asymptote at y equals 0. And we've seen this in the examples. If we had something like x plus 1 over x squared plus 5x plus 6, say. Actually, I'm going to change that. Something like that. Then, when x is a really big number, so think about 1,000, then the top is 1,000 plus 1, and the bottom is going to be 1,000 squared plus some other stuff. That means we've got something around 1 over 1,000 there. Very, very small, so it's going to be close to the axis, and as x gets bigger, that's going to happen more and more. So that's why we have a horizontal asymptote, which is the x-axis. If the degree of p of x is q of x, then there is a horizontal asymptote at y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. We only had one example like this, so let's just think about that again. Let's suppose we had something like 2x squared minus 5x minus 7, and on the bottom we had 3x squared plus x plus 1. Then when x is really, really big, you can essentially ignore all of that stuff. And we've got 2x squared over 3x squared. Cancel the x squared. It will be 2/3. That's the leading coefficient. So that's how that works. If the degree of p of x is greater than q of x, that's when we do the division, then there is no horizontal asymptote. It will be an oblique line if the difference in degrees is 1, and parabolic if the difference in degrees is 2. This is the case. If you have some sort of cubic, like this, divided by a linear, if you have something like that, then you would actually, when you do the division, get the quotient on top here being a quadratic. And that means that you would have a curve as an asymptote. It's called a curvilinear asymptote. But it isn't in the course, so you don't need to know about that. You only need to know about oblique linear asymptotes.